So my network is little bit slow.
No problem.
Are you getting my voice, all of you?
Yes, sir,
Yes,
your
sir.
voice is audible.
Yeah, okay. So then fine, man. In last class, we discussed about the isomerism part. Okay. So next, we will discuss about what is the next concept we are having means here. So isomerism, nomenclature part, and exam point of important is another one is here. Purification of the organic compounds. One it is that qualitative analysis and quantitative analysis. One it is that here. Okay. So first, which one we can discuss here? So better I will go for 1 second. Right now, another one important concept it is that. So that's why I started here. Just I would like to check it out the concepts. What are the concepts we are having? Okay. So now the next, what is the main important concepts we are having based on that one? Which one they are asking the questions that all means here? Let us see. First, cleavage of the bond. So we have a bond cleavage mark. Okay. Organic compounds are containing which type of the bond mark here? Organic compounds are contains which type of bonds? They're the covalent bond, ionic bond. Which type
Covalent
of
bonds.
covalent bonds? What is the covalent bond?
Sharing of electrons.
So mutual sharing of electrons between two atoms is called as a covalent bond. So mutual sharing of electrons between two atoms is called as a covalent bond. Okay. Now in this one here we have a two types of the cleavage. How many types of the cleavage we are having means here? Two types of the cleavage. So that is only we can call as here bond cleavage. Bond cleavage. Sir, what is meant by the bond cleavage? Means whatever the covalent bond it is there in between two atoms, that we can call as a that we are going to be break. The breaking of the bond also we are having two types. So one is called as a homolytic cleavage. Homolytic cleavage. Another one is heterolytic cleavage. Okay, so one is called as a homolytic cleavage. Another one is called as a heterolytic cleavage. Okay, so first of all, any molecule we have taken. For example, if I'm going to take as a 2 chlorine molecule, so chlorine can be exist in a molecule form here. So in molecule form means here chlorine is having 2 chlorine atoms. That 2 chlorine atoms are connected with one covalent bond. Okay, formation of the one covalent bond, how many electrons are required means here 2 electrons are required. Okay, now you got the clarity ma. Okay, in between two nonmetals, one bond it is there. The formation of the bond is 2 electrons are required. Sir, what the 2 electrons how you are going to be break means here? So what is mean by the homolytic cleavage means symmetrical cleavage of covalent bond is called as a homolytic cleavage. Okay, so what is the symmetrical cleavage means here? So the bond, 2 electrons, whatever the 2 electrons are there in between two atoms, equally we are going to distribute to the 2 atoms is called as a homolytic cleavage. Okay, the symmetrical cleavage of 2 electrons are covalent bond. Okay, symmetrical distribution or symmetrical cleavage of covalent bond in between two atoms is called as a homolytic cleavage. So based on the homolytic cleavage, for example, if you divide these two electrons to this one, each chlorine atom is containing one electron. This one also is having one electron. This one also is having here one electron. Okay, so each chlorine atom, it contains an odd number of electrons. Okay, each containing it here odd number of electrons. Odd number of electrons. Okay, by the symmetrical cleavage we can get as here. By the symmetrical cleavage, atoms are having odd number of electrons. Okay, the atoms or molecules which are containing odd number of electrons is called as a free radicals. So what is the free radicals here? The atoms or molecules, the atoms or molecules which contains odd number of electrons. Odd number of electrons is called free radicals. Is called free radicals. Okay, so by the homolytic cleavage we'll get as a free radicals. So free radicals are reaction intermediates. Okay, so free radicals are reaction intermediates. So that we are going to study in the next step. So directly we are going to study about here attacking reagents and reaction intermediates. There we can completely study about the free radicals. Okay, next heterolytic cleavage. Heterolytic cleavage. Now we had seen as a homolytic cleavage. The second one we can see as here heterolytic cleavage. Heterolytic cleavage. So what is meant by the heterolytic cleavage? What we can call as a heterolytic cleavage? Okay, heterolytic cleavage is nothing but unsymmetrical cleavage of the covalent bond. Okay, unsymmetrical cleavage of covalent bond. Unsymmetrical cleavage of covalent bond is called as a heterolytic cleavage. So what is the heterolytic cleavage, ma? Heterolytic cleavage is nothing but here it is unsymmetrical cleavage of heterolytic covalent bond. Heterolytic bond is called as a heterolytic bond is called as here heterolytic cleavage. Okay, sir, what is the example for that? Means again I'm taking as a chlorine molecule only. I'm taking as a chlorine molecule. In between the chlorine we have a one single bond. Let us see unsymmetrical cleavage means. In this one, sir, unsymmetrical cleavage means here unequal distribution of electron. That means one chlorine atom is two electrons are shifted towards to the one atom. If two electrons are shifted towards to the one atom, that atom get as a negative charge and another atom will get as a positive charge. So by the unsymmetrical cleavage, we'll get as a charged species. So one is Cl plus, another one is Cl minus. Okay, so Cl plus and Cl minus. In this one, positively charged ion is called as a Cl plasma. So positively charged ion is called as a cation. Okay, and negatively charged ion is called as a anion. Okay, by the unsymmetrical cleavage, what we will get means here, by the unsymmetrical cleavage, we will get as a charged species. Free radicals, charged species are highly reactive. They are highly unstable. Clear? Okay. Next
Yes,
one.
sir.
Next point here. So what is the next one means here? Attacking reagents. Okay, attacking reagents. What are the attacking reagents on there? Attacking reagents. What are the attacking reagents we are having? Sir, we have two types of the attacking reagents are there. So one is called as a electrophiles. Another one is called as a nucleophiles. So what is meant by the electrophile, which we can call as a electrophile? Okay, so sir, in this one, electro is nothing but electrons. So philic is nothing but loving. Actually, it is the Greek word, ma. Okay, in Greek word, philic is nothing but here loving. Okay, or attracting. So based on this one, how we can define as electrophiles means the atoms or molecules are which attracted towards to the electrons, okay, or which attracts the electrons is called as electrophiles. Simply we can call as electron loving molecules are called as electrophiles. Electron loving molecules or atoms are called as electrophiles, okay. And here electron seeking molecules also we can call as electrophiles, okay. Electrophiles means here electron loving molecules are called as electrophiles. We have two types of the electrophiles, okay. So two types of the electrophiles. So what are the two types of the electrophiles means here? So positively charged electrophiles and neutral electrophiles. So one is called as positively charged electrophiles. Sir, what is meant by the positively charged electrophiles? Which we can call as a positively charged electrophiles means here, whatever the electron deficient it is there. Now only we had seen chlorine will get as a positive charge. That is the one electron deficient it is there. Okay, so positively charged ions are called as a electrophile. Sir, what are the examples of the electrophiles means? H plus, Cl plus, Br plus, okay, I plus, and H4 plus, okay, H2O plus, H3O plus, H3O plus, NO2 plus, NO plus, NO plus, nitrosonium, CH3 plus, methyl carbocation. All these are the examples of the positively charged electrophiles. Okay, and which we can call as a neutral electrophiles. Which we can call as neutral electrophiles. Okay, neutral electrophiles. Neutral electrophile. So what are the examples of the neutral electrophiles? What are the examples of the neutral electrophiles means here? BF3, BCl3, BBr3, okay, AlCl3, FeCl2, FeCl3, ZnCl2. So all these are the examples of neutral electrophile. Sir, how you are telling that all these are we can call as a neutral electrophiles means there is no charge on the molecules. Is these molecules are having any charge, man? Is they having any charge here?
No, sir.
There is no charge on the molecules, but they act as a neutral electrophiles. Sir, why they act as a neutral electrophiles means because of they having the vacancy d or vacancy orbital. So why they act as a neutral electrophiles means because they have vacancy orbital, because they have here vacancy orbital. So whenever they're having the vacancy orbital, they act as a neutral electrophiles. Okay, all neutral electrophiles also we can call as a Lewis acids. All Lewis acids also they act as a electrophiles. Okay, so what is meant by the Lewis acid? Last chapter only we studied. What is meant by the Lewis acid? What is meant by the Lewis acid?
Electron acceptors.
Very good, ma. Electron acceptors are called as here Lewis acid. So all Lewis acids are they act as a electrophiles. So now you got the clarity. Okay. And second one is nucleophiles. Okay. Second one is here nucleophiles. Nucleophiles. In this one. Sir, what is meant by the nucleophiles means here nucleus loving atoms or molecules. Atoms or molecules or ions are called nucleophiles. Okay, nucleophiles. Again, nucleophiles are classified into two types. So what are the nucleophiles we are having means here? Negatively charged nucleophiles. Negatively charged nucleophiles. Sir, what are the examples of the negatively charged nucleophiles means here? F minus, Cl minus, Br minus, I minus, OH minus OCH3 minus OCH3 minus C2H5O minus NO3 minus HSO4 minus. So all these are the nucleophiles. Negatively charged ions are we can called as a nucleophiles. Okay, negatively charged ions are we can called as a nucleophiles. In this one, sir, why they are calling us nucleophiles means negative charge. All are anions. They're having more electron density. So they have to attract the positively charged ions. Actually, what you can call as a positive charge ion here, nucleus is having positive charge only now. Because of the nucleus, positive charge protons are present are there. Okay, so in nucleus, protons and neutrons are there. That's why nucleus is having only positive charge. So that's why they're attracting towards to the nucleus. The atoms or molecules or ions which are attracted towards the nucleus is called as a nucleophile. Okay, and neutral nucleophiles also it is there. So what is another one means here? Neutral nucleophile. So what is mean by the neutral nucleophiles? Okay, so what is mean the neutral nucleophiles means here? The atoms or molecules here which have tendency to donate the lone pair of electron. What are the examples of the neutral nucleophiles? Means ammonia, NH3, okay, primary amine, R bond, NH2. Sir, how they act as a neutral nucleophiles means they have a tendency to donate the lone pair of electron. And simply what we can call means all Lewis bases. All Lewis bases are they act as a neutral nucleophiles. Okay, all Lewis bases are they act as a neutral nucleophiles. Water molecule also it act as a nucleophile. So why sir means here because of it has a two lone pair of electron. And ethyl alcohol C2H5OH. In C2H5OH and oxygen atom we have a two lone pair of electron. It is also act as a neutral nucleophile. And ethers also they act as a neutral nucleophiles. O bond R. Thioethers, thioalcohols, all those are the examples of the neutral nucleophiles. Now we got the clarity.
Yes,
Got it
sir.
all of you? Okay, so all these are the different types of the attacking reagents we are having. Okay, so after that, sir, reaction intermediates are there. So what is the next concept we are having? Important concept means here, reaction intermediate. Okay, so this next concept means reaction intermediate. Reaction intermediate. Sir, what is meant with the reaction intermediates means here? During the chemical reaction, actually all chemical reactions are they're going to be completed only one step. Srita,
No, sir.
all chemical reactions are they're going to be completed only one step. Huh? They won't be completed in one step. They completed more than one step also. So whenever they're completing more than one step means we are going to observe some of the reaction fragments. Reaction intermediates are there. Okay, so in middle of the reaction some fragments are forming. That is only we can call as a reaction intermediate. So what are the reaction intermediates we are having means we have different types of the reaction intermediates are there. Okay, in that one, first one is called as a free radicals. First one we can call as here free radicals. Okay, free radical. Sir, which we can call as a free radicals means here, first of all, the atoms or molecules which contain odd number of electrons. Odd number of electrons is called as a free radicals. Free radicals are obtained by homolytic cleavage. Free radicals are obtained from here, homolytic cleavage. Okay, so free radicals can be represented with dotted symbol. So how we are going to represent ma? So free radicals can be represented with here dot symbol. Okay, and free radicals are paramagnetic in nature. Free radicals are here paramagnetic in nature. In nature. Free radicals are here paramagnetic in nature. So now you understood here all this one. So one is free radicals are odd number of electrons here. They are obtained from the homolytic cleavage. How we are going to represent means here they are going to represent with the dot symbol. So free radicals are paramagnetic in nature. Okay, clear? And where we can observe means here, sir, chlorination reaction it is there. Haloalkanes, haloarenes chapter you already studied here. Okay, so actually free radical reaction mechanism is going to be completed in 3 steps. How many steps here? 3 steps are there. Okay, so there we are going to study clearly about this one. Clear? Next, carbocation. Second reaction intermediate. Carbocation. carbocation. So what is mean by the carbocation, which we can call as a carbocation? Okay, sir, which we can call as a carbocation means here positively charged carbons. Positively charged carbon. Positively charged carbon is called carbocation. It's called carbocation. Okay, so it is obtained by the heterolytic cleavage. It is obtained from here, heterolytic cleavage. It is obtained from here, heterolytic cleavage. Okay, now let us see, sir. Sir, for these two concept is same here. Let us see. First, for example, I am writing as a methane only. Methane, what is the molecular formula of the methane? CH4. Okay, what is the molecular formula of the methane? CH4. That means CH3 bond H we can write. In between the carbon and hydrogen, if it undergoes to the unsymmetrical cleavage means it forms as a CH3 plus H minus. This we can call as a carbocation. Okay, this we can call as here carbocation. Now in this one, my question is, so what is the hybridization of the carbon? What is the hybridization of the carbon in a methyl group, methyl carbocation? And same concept, if it undergoes the symmetrical cleavage means it forms as a methyl free radical. CH3 radical is going to be formed. Methyl free radical is going to be formed here. It is going to be methyl radical.
Sir, is it sp2 hybridization?
Very good, ma'am. It is here. In both the cases, it exhibits as a sp2 hybridization. If it is sp2 hybridization means what is the shape? Carbocation free radicals are having which kind of shape?
Trigonal planar.
Trigonal planar. So what is the bond angle we can expect here? 120 degrees. So what is the bond angle? It will be that means here. So bond 120 degrees. Okay. So first of all, what is the shape? Means shape of the molecule is trigonal planar. And what is the bond angle? Means 120 degrees. Okay. Now, so according to the stability order, actually which one is more stable in both the cases means here benzyl carbocation and benzyl radical is more stable. CH2 radical is more stable. After that, allyl radical, CH2 double bond, CH bond, CH2 radical or CH2 carbocation. After that, actually, if you compare these two means here you will get as a tertiary marker. Okay, here you will get as a tertiary. So tertiary carbocation or tertiary radical is more stable than benzyl and allyl. After that, secondary. After that, primary. Sir, actually, tertiary is more stable means no here. So tertiary radical or tertiary carbocation is more stable. Why the tertiary carbocation is more stable means the stability of the carbocations free radicals can be explained based on electron displacement reaction. That is next step. It is there we can study about that one here. Okay. So this is the just we have to remember reactivity order. What is the stability and all they're asking here. So that's why I had given. Next, carbene ion. Carbene ion. So what is mean by the carbene ion? So what is mean the carbene ion means here? So the carbon which contains negative charge or negatively charged carbon is called as a carbene ion. Negatively charged ion. Negatively charged ion is called carbene ion. Negatively charged carbon is called as a carbene ion. Carbene ion. Negatively charged carbon is called as a carbene ion. Okay. Next, negatively charged carbon is called as carbene ion. So carbene ion is obtained by the unsymmetrical cleavage. Sir, how we can write this? Methyl CH3 minus I am writing here. This we can call as a methyl carbene ion. This we can call as a methyl carbene ion. So what is the hybridization of the methyl carbene ion means it exhibit as a sp3 hybridization. Sir, how you are telling that it exhibit as a sp3 hybridization means it has a 3 bond pair of electrons plus 1 lone pair of electron it is there. So due to that reason only it exhibit as a sp3 hybridization. And what is the shape of the carbene ion means it exhibit as a pyramidal shape. So which shape it is going to be exhibit? It exhibit as a pyramidal shape. Okay. And what is the stability of the carbene ion? Stability of carbene ion. Stability of carbene ion. So what is the stability of the carbene ion means here? In this one, methyl, that means CH3 minus is more stable. After that, primary carbene ion. After that, secondary carbene ion. After that, tertiary carbene ion. Sir, before that one also, one more also it is there. So benzyl carbene ion also it is there. CH2 minus. After that, allyl carbene ion also it is there. Allyl carbene ion. After the allyl carbene ion, methyl, primary, secondary, tertiary. Sir, how we are going to explain this one is this also it is going to be explained based on the electron displacement reactions. Okay, so here you may get that out. So what is meant by the primary carbon? What is meant by the secondary carbon? And what is meant by the tertiary carbon? So what is meant by the primary carbon, ma? Do you have any doubts in that one? What is meant by the primary carbon? Which we can call as a primary carbon. What is meant by the primary carbon? Do you have any clarity about that one? Sriyuta?
When it's attached to a singular carbon.
Very good one. Let's see. I'm writing as some structures. CH2 bond, CH2 minus, CH3 bond, CH bond, CH3 minus, CH3 bond, C bond, CH3 bond, CH3 minus. Okay. Now you can check it out here. In this one, which one is called as a primary carbene ion means this one is called as a primary. Sir, why how you are calling as a primary carbene ion means that charged carbon which is attaches with the neighboring only one carbon is called as a primary carbon. Okay, the charged carbon which is attaches neighboring only one carbon is called as a primary carbon. The charged carbon which is attaches with the neighboring two carbon atoms is called as a secondary carbon. Okay, the charged carbon is attaches with neighboring two carbon atoms is called as a secondary carbon. The charged carbon which is attaches with the neighboring three carbon atoms is called as a tertiary. Okay, so this we can call as a primary, secondary, tertiary. Now we got the clarity here. Okay,
Yes, sir.
next one. So carbene ion. So one more reaction intermediate. So what is another one means here? Carbene. Carbenes. Okay, I think so. You may go. You may listen about this word also. Sir, where you listen about this one means here Reamer-Teamer reaction. One reaction it is that aldehydes, ketones, carboxylic acids, and phenols also you will get in phenols chapter. When the phenols are treated with the chloroform in presence of NaOH, it forms as a salicylaldehyde. What is the product it forms means here? It forms as a salicylaldehyde. Okay, in the formation of the salicylaldehyde. So what is the reaction intermediate means? Dichlorocarbene. Okay, sir, how you are getting as a carbene? Actually, what is the carbene means here? On carbon atom, it is having one lone pair of electrons means. Okay, the carbon which is having one lone pair of electrons and two bond pair of electrons is called as a carbene. Okay, how many lone pair of electrons are there? One lone pair it is there. Okay, this is only one lone pair, and it has a two bond pair of electrons are there. That is only we can call as a carbene. Okay, so carbenes are obtained by removal of the two atoms from the same carbon atom is called as a carbene. How we are getting as a carbene means here? By removal of the two atoms from the same carbon atom is called as a carbene. Okay, now in this one, so if you see the carbenes, what is the hybridization of the carbenes means sp2 hybridization, and what is the shape means here? Bent shape. Okay, bent shape one or V shape or angular shape also we can call it. Okay, again we have two types of the carbenes are there. How many types of the carbenes are there? Two types. So one is called as a singlet carbene, another one is called as a triplet carbene. Sir, what is mean by the singlet carbene means here, at carbon atom we have a vacancy p orbital. If two electrons are present at same orbital, means that we can call it as a singlet carbene. In a carbene, we have a vacancy p orbital. Two electrons are present in two different orbitals, means that we can call as a triplet carbene. Okay, singlet carbene is, it exhibit as a sp2 hybridization. Okay, and it has sp2 hybridization, and it is stable. It is a diamagnetic nature. Okay, it is here diamagnetic nature. So triplet carbene also exhibit as sp2 hybridization. Sorry, sp hybridization. In this one, this exhibit as sp hybridization. It is a paramagnetic nature. Paramagnetic nature. Okay, magnetic nature. In this one, two unpaired electrons are present in two different p orbitals. Okay, what is the diamagnetic and what is the paramagnetic nature? Javion, what is mean with the paramagnetic nature and what is mean the diamagnetic nature?
Sir, in paramagnetic, there are unpaired electrons, and in diamagnetic, they are paired.
Okay, diamagnetic means there are here, so paired electrons are there. Paramagnetic means here, there are unpaired electrons are there. Okay, clear? And if we see in this one here, what is the another reason how we can say diamagnetic and paramagnetic means? Diamagnetic means here, the substance which does not attracted towards to the external magnetic field is called as a diamagnetic field. Okay, or paramagnetic means here the substance which is attracted towards to the external magnetic field. Okay, so the substance which is attracted towards to the external magnetic field is called as here paramagnetic field. Okay, now we got the clarity.
Yes, sir.
We got the clarity, ma. Okay, now this is about the reaction intermediates. Okay, so these are the here different types of the reaction intermediates we are having. So based on that one, shall we see? So different types of the reactions. Okay. Right, ma'am. So we have a different types of the reactions are there. So what are the different types of the reactions? Do you have any idea types of reactions? Any one of you, Devian, Sriyuta, what are the types of the reactions we are having?
Addition, substitution,
Very good.
elimination, and rearrangement reactions.
So types of reaction. We have a different types of the reactions. We have a different types of the reactions. So what are the different types of the reactions we are having means here? One is addition reaction is there. One is addition reaction. 1 second. Kiran. Sorry, ma. So what are the types of the reactions we are having means here? We have a different types of the reactions are there. So what are the different types of the reactions means here? So one is addition reaction. One is addition reaction. Addition reaction. Second one is substitution reaction. Second one is substitution reaction. Substitution reaction. Third one is elimination reaction. Elimination reaction. Fourth one is rearrangement reaction. Rearrangement reaction. Fifth one is polymerization reaction. Fifth one is polymerization reaction. Okay, so now you got this here. So all these are the different types of the reactions we are having. Okay, so all these are here. We are having different types of the reactions. Okay, now in this one here. So what is mean by the addition reaction? What is mean by addition reaction? What is mean by the addition reaction? What is mean by the addition reaction, ma?
When the substrate and the reagent combine together to form a single product.
Okay, so addition reaction means here when the substrate molecule is attaches to the reagent, it forms as only one product. Okay, when the substrate molecule is attaches with only one reagent is called as a addition reaction. Okay, right, sir. What are the examples of the addition reaction? Again, how many types of the addition reactions are there? Means here actually we have three types of addition reactions. So how many addition reactions are there? We have three types of the addition reaction. Okay, so addition reaction. So what is meant by the addition reaction means when the substrate molecule is attaches to the reagent or attacking reagent is called as a addition reaction. Now already we had seen what are the attacking reagents means. We have electrophiles and nucleophiles are there. Okay, electrophiles and nucleophiles. By attaching that one, once you check it out here. So first, based on that one again, we have three types of the addition reactions. One is electrophilic addition reaction. Electrophilic addition reaction. So one is called as here electrophilic addition reaction. So where we had seen the electrophilic addition reaction, where we are going to observe electrophilic addition reaction. Electrophilic addition reaction can be observed in alkenes, chemical properties of the alkenes. When the alkenes are CH2 double bond CH2, it is reacts with HBr. If it reacts with HBr means it forms as a ethyl bromide CH3 bond CH2Br. It is formed as here ethyl bromide. So in this one is called as a substrate molecule. This one is called as a reagent. Okay, so when the substrate molecule is attaches with the reagent means how many products we got here? We got only one product now. If you got only one product means that is only we can call it as a electrophilic addition reaction. Sir, what is meant by the electrophilic addition reaction? In which where we are going to be observed means here. First, the substrate molecule is attaches with the electrophile. Then the reaction is followed by addition of nucleophile is called as a electrophilic addition reaction. So what is the electrophilic addition reaction, ma? First, the substrate molecule is attaches with the electrophile. Then the reaction is attached with the nucleophile. Okay, then the reaction is followed by attachment of the nucleophile is called as a electrophilic addition reaction. Got the clarity statement about here? Everyone will get as a confusion at statement only.
Yes, sir.
Okay, where we are going to observe the electrophilic addition reaction means here Markovnikov rule. Markovnikov rule we can call. Okay, so by the Markovnikov rule, we are adding as a HBr, addition of water, addition of sulfuric acid, oxymercuration, demercuration reaction, addition of ammonia. All these are the examples of Markovnikov rule only. Okay, all these are the examples of electrophilic addition reactions only. Sir, where we are going to study about the Markovnikov rule and it all means here. Sir, in the preparation of the haloalkanes, that where we are studying here. And we are going to study under the chemical properties of the alkenes. In the chemical properties of the alkenes also we are going to study about the Markovnikov rule. So organic chemistry is interlinked to one chapter to another chapter. If you understand these basics, actually GOC is all basic concepts are there. If you understand all these basics, means remaining concepts are very easy. It is very easy only. Okay. Now you understood here what is meant by the electrophilic addition reaction.
Yes, sir.
Okay. And what is another one means here? Nucleophilic addition reaction. It is that. Another one is nucleophilic addition reaction. Nucleophilic addition reaction. So where we are going to observe the nucleophilic addition reaction? First of all, what is the nucleophilic addition reaction? So nucleophilic addition reaction is nothing but first the substrate molecule is attaches with the nucleophile. Then the reaction is followed by addition of, okay, then the reaction is followed by addition of electrophile is called as a nucleophilic addition reaction. So what is the nucleophilic addition reaction means here? For the substrate molecule first attaches with the nucleophile, then the reaction is followed by addition of electrophile is called as a nucleophilic addition reaction. What are the best example for this one means here? Carbonyl compounds. Carbonyl compounds are it undergoes to the nucleophilic addition reaction. What is the example of the carbonyl compounds? What are the examples? Aldehydes and ketones. That means C double bond O group. If you see, there are so many reactions we wrote here. If it is attaches with the hydrogen cyanide, carbonyl compound. If it is attaches with the hydrogen cyanide, means it is converted into hydroxycyanide, cyanohydrine. This we can call as a cyanohydrine. Formation of the cyanohydrine is example of nucleophilic addition reaction. Got it? And one more. Free radical addition reaction. Free radical addition reaction. Third one. Free radical addition reaction. Free radical addition reaction. So what is the best example of the free radical addition reaction means here? Anti-Markovnikov rule. Anti-Markovnikov rule. Okay, sir, what is the anti-Markovnikov rule means? Same alkene CH2 double bond CH2 Okay, actually when we can take means unsymmetrical alkene we have to take. That means if you take as a propene, if the propene is treated with HBr in presence of hydrogen peroxide, so the reaction is carried out in presence of peroxide only. Then only it undergoes to the free radical addition reaction. If peroxide is not there, then it undergoes to the Markovnikov rule. Okay, so that's why the reactions are carried out in presence of peroxide. And one more condition also it is there. So by the free radical mechanism, we can add only HBr. It is not possible to attach HCl, HF and hydrogen iodide. So, okay, so which one is we are going to be added attaches to the substrate molecule means only hydrogen bromide. Got the clarity? So what is the product it is going to be formed means we'll get as a primary alkyl halide. CH3 bond, CH2 bond, CH2 Br. So this is the product. So these are the different types of the addition reactions. So remaining part will continue by tomorrow. Okay?
Okay, sir.
Right, ma. Thank you all. Thank you, Javian.
Thank you, sir.
Thank you, Master Geeta. We'll continue in the next class.